Hi there, I'm Mr. Hawkins, Head of Science at Thomas More Catholic School. Today I'm going to teach you about how to calculate moles, mass, or relative formula mass. Today's success criteria is to understand the meaning of a mole, to be able to calculate the number of moles, be able to rearrange the formula to work out moles, mass, or relative formula mass, or molar mass. As a bit of a challenge for those of you who think you can do this, consider how you can then use this calculation as part of working out the concentration of a solution, or how you could include it in, say, for example, a titration question. So just a quick recap on my previous video. What I'd like you to do is to work out the relative atomic mass, or the relative formula mass, in this case it's all formula mass, of the following. You should have got this as your answer. What you'll see is that what you do is you add together the masses. So we know that chlorine is 35.5 and sodium is 23, gives us our 58.5. Where brackets are found, you need to times the atoms out of the bracket. So for example, oxygen here has 4, but it's within the brackets. It's 4 times 3, which is 12 oxygens, and 3 times sulfur, which is 3 sulfur atoms, combined with 2 aluminium atoms to make aluminium sulfate. So the combined mass, or the relative formula mass of that compound is 342. Okay, so the mole. When I googled the mole, this is the picture I first got, okay? In chemistry, we're not interested in the little furry animal that lives under the ground. Some biologists may be more interested. So then I thought I would Google the mole chemistry and Avogadro, who was the founder of this idea. And I found this one, which I thought was quite funny. Hey ladies, take my number, he said. I'm not sure he would have pulled many females looking like that. However, anyway, the important thing is actually the number. So the number here is a very large number, 6.02 times 10 to the power of 23. That is a huge number. And what that number represents is 1 mole. So within 1 mole of anything, you could have a mole of feathers, you could have 1 mole of sweets, you'd have a lot of sweets. But the idea is that there would be that many sweets, or that, in chemistry sense, there would be that many particles. So 1 mole of any atom or compound equates to that number of particles. So how do we calculate a mole? What we do is we divide the mass in grams by the atomic mass, and that will equal a mole. I personally don't like formula triangles because I think they add complication, particularly if you have more than 3 parts to your equation. But here, if you like them, they work for you. I've also put the units here that are relevant: grams and mole, atomic mass and relative formula mass and relative, and they have atomic units. Okay, so let's work through an example. If I am given 12 grams of carbon, what is my number of moles? You should always follow these equations in the same way. You shouldn't try and jump to an answer. You should always show your working to make sure that an examiner understands what you've done, and also you can check back through. If you just have an answer, it's very difficult to understand what you've done without having to do the calculation completely again. So, you write the equation, you can put it in shorthand, but moles equals mass divided by the atomic or molar mass. You then write out what you have. Here we don't have moles, that's what we're trying to calculate. We have a mass of 12 grams, and using our periodic table, we've looked at the atomic mass of carbon, which is 12. You then substitute the numbers into your equation. So moles is equal to 12 divided by 12. Moles equals 1 mole. We know that from our units from the previous equation. What that means is that 12 grams of carbon is 1 mole. You can have a play around with this, but what you'll notice is, for example, 16 grams, which is the atomic mass of oxygen, is 1 mole. 1 gram of hydrogen is 1 mole. It's so important that you get used to using these numbers and how to look them up and rearrange the equation. So what I'd like you to do now is do all of these, or perhaps pick a few between the different grades, and calculate in this case, the mass of 1 mole, in this case, the mass of a mole, and here, the number of moles. If you're working out mass, you obviously have to rearrange the equation, and I've given this to you saying that 1 mole. So 1 mole will equal mass divided by the relative formula mass, and the same for this example, whereas here, where you're calculating the number of moles, you do mass divided by the formula mass. Here's the answers you should have got. Okay, so what we've done in this really short clip today is understand what the meaning of a mole and Avogadro's number. We've also been able to calculate the number of moles, and you've also been able to rearrange the formula to work out the mass. You've done the molar mass here by working out the total mass of the compound using your periodic table, and you've calculated the mole. For those of you who were up for the challenge before, I hope you've gone away and looked at solutions and concentrations. You'll notice the units are in grams per mole. Thank you very much for listening, and I look forward to seeing you again.